Next, let's look at an example where we make some computations, and we will use problem number 4.11, which is a continuation of 4.10 right here. Okay, so we'll use the same data and try to answer the questions here. Okay, so now first, before we answer any of the questions, let's define the following simple events. So first, let's call Y as marketers who plan to increase the use of LinkedIn, and then N is the opposite of that. So N would be not plan to increase use. Okay, so Y and N are complement of each other. And let's now define B is the marketer's focus is business to business, and then C, marketer's focus is B2C. And B and C are mutually exclusive. Okay, now T is the total number of outcomes, right? Total number of outcomes, and we know that is this number. Okay, now whatever probability we want, if you go X divided by this, that's T, that T, where X stands for outcomes in the event, either simple event or joint event, then that will give us the probability. So for example here, the first question is, what is the probability that a marketer selected at random plans to increase the use of LinkedIn? So here this is a simple event that is planning to increase the use of LinkedIn. So the X here is increased use of LinkedIn, yes, so which is that. So now if you take that X divide by T, that will give us the probability of Y. Y being increased use of, planning to increase the use of LinkedIn. Okay. Now B, what is the probability that a marketer selected at random is a B2C marketer? So again, this is a simple event. B2C, that's it. So X here is B. So the event is B, so X is that. So probability is X over T. Okay, now question C is, what is the probability that a marketer selected at random, okay, plans to increase the use of LinkedIn or is a B2C marketer? So this is a little more complicated question. Okay. Now for this we need what is called the general rule. Okay, so now we need to go to PowerPoint and examine those rules, and then we'll come back to this question. So this is not a joint probability. Joint probability would have been, so suppose if the question is, what is the probability that the randomly selected marketer plans to increase LinkedIn and is a B2C marketer? So that would be a joint probability. And joint probability we can immediately calculate B, S and C, right? Y and C, which is that, divided by this will give you the joint probability. But that's not what we want. We want either or probability. So when you have an either or event like A or B, then we can use what is called the general addition rule to compute the probability. And that probability is given by probability of A plus probability of B minus the joint probability of A and B. Okay, why is that? Okay, let's look at this rule in graphical format. So, okay, suppose this Venn diagram represents all possible outcomes. Okay, and then we have an event like that. These are the outcomes that correspond to A. Now, these are the outcomes that correspond to B, and this is the intersection or joint, A and B jointly. Okay. Now if you want A or B, the probability is given by this contour, okay, like that and like that. Okay, so that set will give you the probability or the outcomes contained in either A or B. So which will be, saying it in a different way, this is just A Okay, and then just B, and then A and B. So that would be the, so if you're looking, if these circles represent probability, then you have that probability and then the joint probability, and that probability would give you the overall either or probability. Now if you take A, okay, which is that, then you have to add to that probability of A only this part to get A or B. But if you add B to A, then you're adding this section twice. That's the reason why we add A and B and then remove the joint probability that was double counted. So that's why we have the formula this way: probability of A plus probability of B. And here when we do this, we are double counting the joint probability, so you take away the joint probability one time. Okay. Now, a special case when there is no joint probability, if A and B are mutually exclusive, which means there is no intersection. There is one circle and then that represents A. There is another circle that is completely disjointed that represents a second event. There is no intersection. Then probability of A or B would be just probability of A plus probability of B. Okay, so here is an example: probability of male or stat. So you'll have probability of male, which is 229 over 439, plus probability of stats, taking stats, so that will be 160 over 439, and then you subtract the joint probability, which is 84 over 439. So this is the rule that we have to apply to answer the last question that we stopped with in Excel. So to answer C, we need to use that general rule. So here we want probability of Y, that is, yes, we are going to increase use of LinkedIn. Okay, and the second event is C, B to C marketer. So it is Y or C. So we need probability of Y plus probability of C, and then you have to subtract also the probability of Y plus probability of C double counts the joint probability, so you remove the joint probability once. So we have probability of Y here, we have probability of C right here. So what we want is the joint probability. So we want the joint probability. So for that we have to first get the X for joint probability. X for joint probability meaning the number of outcomes in the joint event, Y and C. So Y and C is that. So the probability of Y and C is that divided by the total number. Okay, so now we have everything we need to find the either or probability. Either or probability is often referred to as the union also. That is Y union C. So Y or C is probability of Y plus probability of C minus probability of Y and C. So that is the probability, or that is the answer for C. Now what about D? Okay. D is explain the difference in the results between B and C. Okay. Now B is probability of only C. That is, the marketer is a B to C marketer. Whereas in C we have that and those who are not C but they are planning to increase LinkedIn. So that part is also added, and that's the difference. So probability in B includes all the outcomes in B to C only. But probability in C includes that and the Y outcomes for B to B as well.